the refining process, we look at what happens when steam is added to a distillation tower. When we have crude oil come in, this is very, very what we call heavy oil. And by that, we just mean that it's long chain hydrocarbons. And so the first part that's going to come out are these asphalts and waxes. And these are more than carbons. They're like more than 20 carbons, long. So they're very complex. And we see this, we drive on asphalt all the time. Okay. The next one that comes off is what we would call gas oil, fuel oil, and actually let's call it diesel fuel oil. And these are roughly 18 to 20 carbons long in all different aliphatic shapes. The next one right above it, there's not a whole lot of difference. There's 157 to 232 is only about 80 degrees. And in here we find our kerosene fuels, lighter fuel oils, and these are 15 to 18 carbons long. So what we're starting to see is that the heavier carbons, they're going to stay at the bottom. And as we get lighter, they're going to be able to be carried up higher and higher. It says here greater than 426 degrees. Okay. The next ones are our naphthas, our refined oils. And these are 12 to 15 carbons. These are the ones that we make money off of, these ones. Okay, our refined oils and our naphthas, our naphthalines. Right out here we have what we call straight run gasoline. This is our vehicle fuel oil here. And these are actually only 5 to 12 carbons long. This one here, up to 32 degrees Celsius, these are what we call our light end hydrocarbons. They are 1 to 4 carbons long. These are what we also call, in the oil and gas industry, we call them our volatiles. So yesterday I was showing you benzene, toluene, ethylbenzene, and xylene, which are all aromatics. Even though there's 6 carbons, they're also very light, the way that they're bonded. So these shorter hydrocarbons, and this just goes with the notes we took the other day, have a lower boiling point. And so then we can condense back out. And collect it at the top. Okay. And it takes multiple tiles to do that. Once we move the hydrocarbons from the distillation tower, then we can process them or purify them even further. So, okay, once they go through this process, then we can chemically modify them or we can purify them. The ones at this particular Dunvegan gas plant, the fuel comes in sour, and so we have to scrub out the H2S, and there's different scrubbers and processes that it goes through there, because you don't make money on sour, and by sour I mean it has H2S in it. You don't make money on sour fuels. You make money on sweet fuels. So a lot of times, if you know somebody in the oil and gas industry, they'll talk about sweet gas or sweet oils versus sour gas. Riley?
Sour gas is
I could have high levels of nitrogen in it. We call those amines, and they contribute to wax buildup as well. But sour typically lends itself to sulfur. SO SOX. Okay. Some fields are naturally sour, some fields are naturally sweet. In this Peace Country region, we're mostly sour. When you go down south, they're mostly sweet. I don't know the difference, but I do know that there's bacteria that love sulfur, and bacteria will degrade your downhole formation, and so you have to put in a bactericide to maintain the integrity of your drilling well. After that, cracking is a process where we break the carbon-carbon bonds. It's exactly how it sounds. And they do it under pressure in the absence of air. You can do it by steam. You can do it by water, being hydro. Or you can do it by catalytic cracking. And as we get further into the course, we'll learn about catalysts. But they essentially take a longer hydrocarbon chain and break it into a smaller hydrocarbon chain. So if we would get 2 smaller chains, because that's where the money is. The money is in the smaller chains. Reforming uses heat, high pressure, and catalyst to convert straight chains into branched chains, cyclic chains, and aromatic. So if we had on reforming, if we had this, we could, under pressure, force it to do this. We could force it to do this. We could force it to do any multitude of things, right? We branched alkanes, cyclic, and aromatic. Okay. And what you're doing is you're creating a carbon-carbon bond. Solvent extraction means that we take an insoluble solvent. So what's insoluble to hydrocarbons? Anything that's polar, because hydrocarbons are nonpolar. And it dissolves any of the impurities in the hydrocarbon, leaving behind pure hydrocarbon product. And then the impurities can be drained off and discarded. And so maybe we have, this is where the money is, and maybe off of this group we have a sulfur group bonded to an O group. Sulfur needs, maybe this is bonded to something else, and we want this piece to come off. So because we know this chain here is nonpolar, insoluble solvent would be most likely polar, would pull this group off. The other thing that you could do is you could have a carbon chain with a halide on it. And halides are soluble in water, and so it would pull this piece off. Potentially, if you reacted it with water, potentially you would get HCl, and then you would get your hydrocarbon chain. Pardon me? Oh, you can't see the bottom. Okay. So that's what you would see.